This is a project that we have been running for, I think this is the third year that we've run this trial, where we are looking at the capacity of a nitrogen-fixing bacteria to supply supplemental nitrogen to the wheat crop. And of course, this falls into that category of biologicals as a, fertility additive or soil health additive. And really, we were just trying to see, can we make this work in wheat systems? So the rationale behind this for growth promoting bacteria is to improve that soil microbial community and add something in there that functions a little bit like the nitrogen fixers that come with your soybean crop. They can fix something, nitrogen from the atmosphere, to provide plants with that nitrogen. There's also been some research that this helps improve a plant's ability to handle stress. Dr. Pagliari, who has the idea behind this, he has a lot of connections back to Brazil, where they are using this technology and really are pretty satisfied with it for their systems. So basically, we just want to see if we can use an inoculum to impact that wheat growth and yield, but then also see if we can sort of, optimize that for wheat systems. And Paolo is also testing this for some other cropping systems. But yeah, today I'm just talking about the wheat. So we have two different field trials that are sort of combined into one. One is a nitrogen rate trial, really going from 0 to 120 pounds per acre of nitrogen for our wheat, with an inoculation, that standard inoculation rate of 100 milliliters, or, it's really a very small amount that gets added to the seed right before we plant. We're also looking at how much of that inoculum you might need to see a response. And we're doing this in Lamberton in southwest Minnesota and also up here in Crookston. And because we have different cropping systems in Lamberton and in Crookston, my two trials were wheat after soybeans and wheat after sugar beets in 2021 and 2023. But we did actually we had enough corn crop in plots to try it after corn in 2022 up in Crookston. In Lamberton, they just did wheat after soybeans and wheat after corn. And we were collecting these soil samples. Before the season started, and also we added a mid-season soil sample to see, is that plant growth promoting bacteria, is this azospirillum that we're using, is it actually doing what we think that it should be doing, which is fixing nitrogen and making it available in the soil? We collected grain yield, and we've also collected grain samples after harvest to look at total N, but that analysis is still ongoing, so I don't have the grain results. We're just going to look at yield today and some of the soils too. For the soils N, we didn't see any effect on the nitrate and ammonium, the inorganic nitrogen, after inoculation immediately, but midway through the growing season, we did see a little bit of a boost in that nitrogen rate. So we could actually see that, yes, we inoculated the soil and there was some additional nitrogen in the soil. In Lamberton, what Paolo has here is that soil inorganic N increased to 25 parts per million after soybeans and then 9 parts per million after corn. And then in Crookston, we had 30 parts per million after soybeans and 53 parts per million after sugar beet. So then, of course, the next is, how does that translate into yield? Well, and all of these graphs that I'm going to show on the next slide are the same, so I'm just going to kind of talk you through, because I know the text on these is small. But we have the nitrogen rate from 0 to 120 going from left to right. And the darker color is the non-inoculated, and the lighter red is the inoculated. So what we saw for grain yield in Lamberton is that we actually did get a response of fixing nitrogen, but only when we didn't apply any nitrogen. And the same thing was for wheat after soybean. So both wheat after corn and wheat after soybean. But wheat after soybean, we actually saw that effect of that bacteria being able to fix nitrogen all the way up to an equivalent of adding 60 pounds per acre of nitrogen. After that point, once you added 90 pounds of nitrogen or more, then you didn't really see any impact of that bacteria anymore. In Crookston, a similar story for wheat after sugar beets. Again, at that 0 pounds per acre rate, we saw that nitrogen fixing bacteria was able to supply more nitrogen than just planting it without anything. But we didn't see any effects once you added more nitrogen to the system, there really wasn't an effect anymore. We did see something a little bit strange. Wheat after soybeans, adding the inoculum did actually cause a decline in the yields relative to the non-inoculated system. And since we have not we haven't run those grain samples yet, we haven't really fully looked at this data analysis yet. I can't explain exactly why that happened, but that is something that we're going to want to dig into a little bit to see why in 3 out of the 4 cases we saw that response at 0 pounds per acre, but this one time we saw the opposite. It could just be an anomaly or it could be something else there. We're going to have to dig into that. And as I mentioned, the grain protein samples are currently being processed. And when we start to look at the inoculum rate, we didn't see any differences in Lamberton about how much inoculum was added. So it didn't matter if you added a little bit or a little bit more. That didn't seem to make a difference in the yields. In Crookston, again, we saw that for wheat after soybeans, again, no effect of the inoculum. There was, again, a significant response. This time it was in wheat after sugar beets that we saw the inoculum rate to higher inoculum or have the presence of inoculum reduce to the yield. So again, another kind of strange anomaly that we're going to really need to dig into more. So just to summarize this, in 2023, we didn't have any effect on the inorganic levels in the soil, but we did increase grain yields about 15% at that 0 pounds per acre rate. So if you weren't going to apply any nitrogen, adding the inoculum is better than not adding any nitrogen. But once you got above that 60 pounds per acre, we didn't see any effect of that inoculum anymore. And so the 3-year research shown that the wheat following soybean would not need additional N when it's inoculated. So the future plans of this trial, what Paulo is really interested in doing, one of the things, we've been getting this inoculum from Brazil's version of USDA, and we've been testing a Brazilian product in Minnesota soils. So I think you can imagine why that maybe was giving us not great results. I mean, this isn't the climate that that bacteria is going to thrive in, but we were able to isolate a similar species of bacteria from native Minnesota soils. That's another faculty member, Dr. Satoshi Ishii, who's also in the Department of Soil, Water, and Climate down in St. Paul. And we sent him some soil samples, and he isolated the same type of bacteria. Paulo really wants to take that bacteria and isolate it and then run more research trials using something that we've isolated from our soils. And we will see in the future if we can make that inoculum successfully and test it out.